All right, folks, welcome to 6.3, Addition and Subtraction Formulas. So we're going to start by talking about the addition and subtraction formulas for sine, and then we'll go ahead and talk about the addition and subtraction formulas for cosine and for tangent. So sometimes the addition formula is actually called the sum formula or sum identity, and sometimes the subtraction is actually called the difference formula. Okay, so we have a sum and difference formula or identity for sine. Okay, so for sine, we have the addition formula, and this is when we have sine of two different angles. So let's say one angle is u and the other angle is v. I know those are unfortunate letters to use. One hint I have for you: when you write the u's, maybe put a tail on your u, and when you write your v's, make them super pointy. Okay? So if you have sine of u plus v, that is the same as sine of u times cosine of v plus cosine of u times sine v. And we're going to use this formula in just a little bit, but I also want us to remember or know that that is not equal to sine of u plus sine of v, okay? And you just cannot distribute the sign like that. The order in which you do things matters. So you cannot distribute here. And if we take a look at the subtraction formula, we have sine of u minus v. And the formula looks super similar with one exception. When I am adding two angles and then signing them, it is added in the equation. However, if I am subtracting the angles, so subtraction here, it's going to be subtraction here, okay? So let's be really careful about those signs as we move through a couple examples. All right, first question. Find an exact value for sine of 11 pi over 12. So if I want to think about how do I write this as some angle plus another angle, I know that when I add with fractions, I need to have a common denominator. So let's assume they're both 12. How can I add the top and the bottom to make 11? And so I might notice that if I took 8 and 3, 8 pi and 3 pi, I could get 11 pi over 12. Now those are not nice unit circle values, so maybe it would be easier for us if we reduce those to be nicer values. So 8 pi over 12 reduces to 2 pi over 3, and 3 pi over 12 reduces to pi over 4. And so now we can see that one of our angles is our u, and the other angle is our v. And we also notice that we are adding these two, so we'll have an addition symbol in our formula. So I would encourage you to write out the formula the first few times that you do this, so that you can get a hang for what that formula is, and you don't make a mistake like I just made where you write it incorrectly. So sine v. And now I'm going to plug in the angles I have. So sine of 2 pi over 3 times cosine of pi over 4 minus cosine of 2 pi over 3 times sine of pi over 4. Now, it would be really useful for us to go ahead and have our unit circle out. So let's go ahead and make sure you have your unit circle out, and we'll go ahead and fill in our values. So sine of 2 pi over 3 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Cosine of 2 pi over 3 is 1/2, and sine of pi over 4 is root 2 over 2. Now, if I take the first set of fractions and I combine them into 1, I'll get root 6 over 4. And if I take the second set and combine them, I'll get root 2 over 4. Now, there's nothing wrong with this answer, but typically we write our answers as one fraction. And so this might be a little bit more common than the other one. Okay, let's take a look at example number 2. So example number 2 is asking us to almost go backwards here. They give us the sine and cosine extended formula, but they want us to write it as one angle. So when I look at the formula, I notice that I've got a minus sign here, which means I'm going to have a minus sign in my original part. So let me rewrite this, because one option is that I have sine u cosine v plus cosine u sine v. That would be the sum one. Or I can have sine u cosine v minus cosine u sine v. Now, I know because I have the minus sign that it's going to be the second one. But I also noticed that the sine comes first here, so I need to reorder my original question. I'm going to write it like sine of 82 cosine 61 minus cosine 82 sine of 61. And that is going to be equivalent to sine of the first angle minus the second angle. Or we can write that as sine of 21 degrees. Okay? So that's how we use the formula to go backwards. Okay. Let's take a look at example number 3. So here we've got a case where we are trying to prove something or make one side look like the other side. Now in this case, let's take this left-hand side and try and make it like our right-hand side. The reason why I'm picking this side is because I see that I have the sine of one angle plus another angle. And I know that I can rewrite that as sine u cosine v minus cosine u sine v. And so I'm going to apply that with the numbers and letters that I have right here. So I've got sine x cosine pi over 2 minus cosine x sine of pi over 2 equals cosine x. Now, if I think back to those unit circle values, I know that cosine of pi over 2 is 0, and sine of pi over 2 is 1. And so I can rewrite this as negative cosine plus cosine x equals cosine x. Alright, so that's a good example of a mistake you don't want to make. You want to make sure that you go ahead and make sure all the signs are correct, otherwise you won't end up with the right answer. Okay? So we're going to stop this video here, come back for part 2, where we're going to go ahead and talk about sum and difference for cosine.